All right, so we're going to start talking about trig identities. Right? Do we remember what an identity is?
Your ID.
I mean, yes. Do we remember what it is in math?
When did we learn it?
I mean,
I know, like, the
technically,
identity property, isn't it, like, something 0, 1?
I mean, yeah, so it's basically an equation where no matter what you plug in, it's going to work.
It will work?
It will work. It'll work for any value.
That's mind-blowing.
So, like, when we solved, like, linear equations, when you got, like, all real numbers, right, means you can plug in anything and it's going to work. Okay, so a lot of these we've already kind of talked about. So if you look at your sheet of identities, right, we've talked a lot about the reciprocal ones, right? Right, how sine and cosecant are reciprocals, right? Tangent and cotangent, secant and cosecant, right? So we've talked a lot about those. So like sine is equal to 1 over cosecant, right? Cosecant's 1 over sine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Cosine's 1 over secant. And secant's 1 over cosine. Right? So those are all on that sheet that I handed you. Here. Okay, right. So, like, those are all there.
So when I got to see this little weighted dino elephant, I mean not dino.
Dino elephant?
Little weighted elephant.
That is awesome.
I got carousel lion. I like the elephant better though.
Right, so the other identities that we use a whole lot are those Pythagorean identities. Okay, so the main ones are like the top ones there. So like your sine squared plus cosine squared will always equal 1, no matter what values you plug in for theta. Right, 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Right, so then the ones below it, I've just kind of rearranged, right, because it's going to work no matter what. Which is helpful. And we've talked about how tangent is sine divided by cosine. So then cotangent would be cosine divided by sine, right? Because tangent and cotangent are reciprocals. So you're just flipping it. All right. So the first thing we're going to do is kind of learn how to simplify like trig expressions by using these. Right? So let's say we have tangent theta is equal to, no, not equal, I'm sorry, minus secant theta cosecant. All right, so the first thing it's asking us to do is simplify this by putting it all in terms of sine and cosine, right? So eventually what we're going to do is, all right, don't panic when I say the word. We're technically going to prove that some of these identities are true, not like we did in geometry. Okay, it's more math. It's like, we're not going to do those kind of proofs. Everybody freaks out when I say that. Yeah.
No, I did not like those. I did not understand.
So basically, we're going to have like big kind of equations with lots of trig functions. And we're going to take one side and use our identities to change what it looks like to make it match the other side. Okay? It's actually kind of fun. It's like a puzzle.
I love puzzles.
I know. Everybody should love puzzles because they're fun.
I put together this Lego puzzle, and I got to read like the book, and there was one piece missing.
That's really sad.
You know what's the most tedious Lego I've ever done? Lego flower.
Oh, I know. I
Someone
want
needs
to
to
do
give
this.
me Lego flowers.
I got a whole bouquet of them.
Yeah, where's mine?
Hey, get on the ball. Yeah,
I
I'll take
did.
the ball.
Okay, guys, let's focus. All right, so let's put all of this in terms of sine and cosine. So how can we change tangent into sine and cosine? Looking at our identity sheet.
Cotangent.
No.
Multiply.
No. What is tangent? What are some things that tangent's equal to?
Tangent.
It's 1 over cotangent, right? But that's not really helpful. It is sine over cosine, right? So we're going to change tangent to sine over cosine. Look at the bottom, the quotient identities. Right, tangent is always equal to sine divided by cosine. So I'm changing it. I'm replacing it because I know it's equal. Okay? So what do we know about secant? What is secant equal to? No? 1 over cosine. Right, what is cosecant equal to? No.
What is what?
Cosecant.
Oh, 1 over sine.
1 over sine.
So how do you know what to do with this?
Right, so this example told us to like put everything in terms of sine and cosine, right? Like it wants us to then do this and then simplify it down. Right, so again, we used this for the first one, right? Tangent's equal to sine over cosine. We use the fact that secant is equal to 1 over cosine and the fact that cosecant is 1 over sine. Okay, we changed all of these by using what's on that sheet. Okay, now you don't always have to switch to sine and cosine, but this one's telling us to, so that's what we're going to do. Okay, so then now, how can I simplify this?
A factor.
No. Because really this is, since they're multiplied together, right, I'm going to, but all that does is just kind of squishes them together, right? It's just 1 over cosine times sine. Okay, so if I want to subtract those, what do I have to have?
Numbers.
No.
Division.
How do I subtract fractions? What?
Common denominator.
Common denominator, right? So my common denominator would be what? Times
Sine.
sine, right? Right, so this one already has a cosine. This is cosine and sine. So I have to multiply this first fraction by,
Cosine and sine.
just by sine. It already has a cosine.
Oh, yeah.
Okay. So then that gives me sine squared over cosine times sine. Okay, so what happens when I subtract those two? So on top I get sine squared minus 1, and then the bottom just stays the same. So cosine times sine. Okay, is everybody with me up to this point?
Just 1 sec.
Okay, that's fine.
Halfway there.
All right. So what part have I lost you at?
Why? You just have to keep doing it.
Okay.
It'll come to me.
All right, so now, can we do anything else?
Yes.
What?
I don't know. With
Okay.
the sign,
What about the sign?
make it a 1. Make it squared? Yeah, make it
All right, so it's squared. So if you see a trig function squared and a 1, more than likely that means you want to look here in the middle of the sheet at your Pythagorean identities. Okay, so like we want to look right here. Okay, so which one of those almost makes sense?
Sine.
What?
I don't know.
In the first, one of the first two. I mean, not first column. Is it the second one of the first column?
So,
That's the right number.
what? Yeah, so like we're looking in this first column, right? Because we have sine squared and 1. Okay, so if we want, we can change that sine squared and make it 1 minus cosine squared.
You lost me there.
All right, so now I'm going to see sine squared equals this. So I'm going to change this because that's going to make that 1 go away, right? Because I have a 1 and a minus 1. So it's going to let me cancel those out. All right, so let's do that change real quick. So sine squared is 1 minus cosine squared. Okay, so look, 1 minus 1. Those cancel out. So then now I have negative cosine squared over cosine sine. Now what can I do? I can cancel out a cosine, right? So the one on the bottom is going to go away, and that's going to make that not squared anymore. So I have negative cosine over sine. What's cosine over sine? Close. Cotangent.
And that's it?
Yeah.
Oh. That's a little bit. That's a little, yeah, that's a little bit.
It is.
I feel like I understand the second part that we did there in the first part. Yeah.
All right, what do you mean the second part and first part?
Like when we started doing the second little thing in the column.
This?
Yeah, I feel like I don't understand that as well as I understand where we.
So where I got the common denominator?
Yeah.
Okay. Yeah, so that's one of those things we're going to have to get good at, right?
Yeah, probably.
Okay, so let me talk through how I did it again, okay? All right, so look, so this one had cosine times sine, right? This one just has cosine. So to subtract these, I need them to match, which means I need this one multiplied by sine, right? Whatever I do to the bottom, I also have to do the top, okay? Yeah, so like basically pick the bigger one, multiply the smaller one by whatever's missing to make them match. Does that make sense? Right, so then that's how I got the sine squared, because I did sine times sine, and then sine times cosine. So I just wrote them the same so that I remember that they match. Okay. All right, good. Okay. Let's do another one. Okay, yeah, so let's practice with these fractions. So this one is cosine over sine minus sine over 1 minus cosine. All right, so let's practice getting a common denominator. Okay. All right, so they don't really have anything in common, right? So, kind of annoying, but that just means that we're going to multiply them like by each other, right? No. Sort of, but no. Okay, so like this one needs the 1 minus cosine, right? So I'm going to multiply this fraction by the 1 minus cosine over, all right? Okay, do we know why I did that?
Yeah.
No.
Right, so that's what I have on my other denominator. All right, so basically common denominator. So if you have like 1/2 minus 1/3, right? To get your common denominator, you're going to multiply the 2 and 3, right?
Yeah.
We're basically just multiplying these together to get our common denominator. So this one already has sine, so I have to multiply it by 1 minus cosine.
You have to do whatever on the top you did on the bottom.
Yes, right? So then my other one I'm going to multiply by what, top and bottom? Sine. Good job.
This is smartness. This is smartness.
All right. Abby, did that help?
Yeah.
Not convinced, but okay.
I'm like a wolf.
So like if they don't have anything in common, you just have to multiply them both, top and bottom, by the opposite fraction's denominator. So now, right, we're kind of distributing that through, right? This cosine has to go here and here. So I get cosine minus cosine squared
Wait, what? You kind of lost me.
All right, look up. So I took this. I have to multiply it to this one and this one because we're subtracting that. So you have to distribute it in. If you need to put parentheses. Well, 1 times cosine becomes cosine. Cosine times cosine becomes cosine squared.
Oh.
Right, and then on the bottom, I'm just going to leave that as minus cosine times sine for right now. We might need to do something with that later, but I'm not worried about it at the moment. Then for my second fraction, so sine times sine is sine squared. So then I get that. So now, basically you just kind of smush those together, right? So I have cosine minus cosine squared minus sine squared over just one of those denominators. Right, because once you subtract or add or subtract fractions after they have the common denominator, you're just working with the top. And the denominator stays the same. All right. What are we thinking? Okay. All right, so how can we keep going from here?
Look at your sheet.
Look at your sheet, right? So what do we have? We have a cosine, we have cosine squared and sine squared, right? So usually if you have both of those, that's a pretty good sign, okay? Because look, sine squared plus cosine squared equals what? 1, okay? But ours are negative. So how can we fix that?
Multiply something.
Not quite. Almost. No.
I like your little pun.
Huh?
That's a good sign. That's a good sign.
Ha! Didn't even notice that.
I know.
All right, so we can factor.
Wait, factor what?
Factor out a -1.
Why do we do that?
Yeah, wait, how?
Yeah, why would... I don't even have to ask.
Okay, hold on. All right, look. These are both minuses, right?
Oh,
I need them to be positive, okay?
so why is that?
So I-
minus symbol not in it too?
Because I took it out.
We had like a formula for something a long time ago, and this reminds me of it. Where you use the first thing. I don't know. Yeah, it's just...
All right, so I pulled a negative out of those two. So I took the negative out. It's outside, right? -1. Because, like, if there was a 2 in front of both of those, or a -2, we could take out a -2 and put the parentheses in. We're just taking out that greatest common factor of -1.
Can I put the -1 there? That might...
Sure. Yeah, you can absolutely put a -1 there. All right, so now we know that this is equal to what? 1.
Wait, why?
Because sine squared plus cosine squared equals 1.
Where'd that -1 come from?
It's the same one. I just took it from these two. I took it from this and from this. Took it out. Abby said it would be helpful if I wrote a -1 there instead of just a minus, so I did it. Oh, well, then don't put it there.
I think the whole thing
It's okay.
I know, this one's hard. It's okay. We're getting practice with fractions. Guys,
Wait.
I need you to also to not panic. We're going to do a lot of these together before I just, like, set you free. It's okay. Right? So that equals 1.
Yes.
I don't want the highlighter. There we go. All right, so again, that is now 1.
So what happens with that one?
It's just there now. It's minus 1 because it's negative 1 times 1. All right. Can we cancel anything?
Cosine?
Not quite. Almost. Right. So we have cosine minus 1 and 1 minus cosine.
Yeah, I was kind of like.
So they're really similar, but how can we change it to make them look the same?
Switch them, the numbers.
I mean, almost. Because I have negative 1 plus cosine.
Cosine negative.
So if I take out a negative 1,
Make the cosine negative.
if I divide both of, all right, so let's say I have that. All right. If I divide both of those by negative 1 on top, what do I get? So negative 1 divided by negative 1 is what?
Wait, divide what by negative 1?
This.
Why'd you make that instead of the other way?
It changes them.
You lost me. Wait, I don't understand why you put that there.
Okay, so basically, if you have two things that are the same numbers but the signs are flipped, take out a negative 1 and they will match. I thought we've done this before.
No. Well, we probably have. I just don't understand. So cosine minus 1 is the same thing as negative 1 plus cosine? Is that the same thing?
Yes, I just switched the order.
So, okay.
Yeah. So these are the same.
Oh. Okay. Wait.
And then here, I divided out a negative 1.
Wait, so what am I writing? I'm so confused. What?
This is so bad.
Okay. I feel like I made it worse by doing that.
Well, that was...
It's okay.
I needed help understanding. What do you mean?
All right. Let me just... Okay, so we need this
Yes.
to look like this before we can cancel it out. Right? So to do that, to flip it around, you have to take out a negative 1. And then that makes it go like this.
Wait, take the negative 1 out of the top one?
Yes.
Okay.
You could technically do it on the bottom also and flip that one.
Where did you get the 1 on the inside, though, then? Of the parentheses?
That's what I'm confused about. Or the one.
How'd you get... You have 2 different ones. How did you do that?
There, okay. Because this is where I lost you guys last time. Right? So if I take out the... Technically, then, that would be negative cosine plus 1. But then I just switched them around to get here. Because cosine divided by negative 1 is negative cosine. Negative 1 divided by negative 1 is positive 1. Okay? But I wrote it like this so that it matches this.
So you can just write that.
If they're flipped around, take out a negative. Yes. And it flips
You
it.
might keep that same number there, though. But a positive.
Yes?
I'm gonna shut up. I'm gonna stop talking because I think I'm just
You're
making things
confusing
worse. Yeah.
Yeah, if you have to flip it, take out a negative.
Okay.
I think that's the easiest way to make it make sense.
If that was a rat, this is what I make. Rats are so cute. I don't understand why people hate
Okay, but now, look. Those cancel. So I'm left with my negative 1 over sine.
Yeah.
Right? So that negative trick is helpful for when you need to flip stuff around to get it to cancel.
Oh, no, you didn't. Oh, this is good. Yeah, this is was like,
All right, so what's 1 over sine equal to?
Isn't it negative 1?
Well, yes. Right, so 1 over sine is cosecant, so you just make it negative cosecant.
yes, it says on the paper. Oh, wait. Wait, why? Oh, okay.
Why did I what?
Never mind.
Negative 1 over, where's that at?
Well, it's 1 over sine, but it's just negative, so then you just make it negative. It is crazy.
This whole thing is so much.
Do you want to do one more? I think we should.
I think we should because
You are smart. All right, so let's say I have this. Okay, let's say I want to get rid of the fraction. I don't want any fractions in it. They are friends, I agree. But sometimes when we are learning to prove these identities, we have to get rid of fractions.
sometimes we have to put our friends away to focus on ourselves.
Okay, anyway.
I made that mistake when you're.
All right. So, how do we get rid of stuff on the bottom of a fraction?
You have to
Put it on the top.
cancel something out.
We have to multiply it by something. No.
On the top. The opposite on the top.
You have to.
Okay, you're not.
By sign.
Not wrong, but just not right.
Okay, we have to multiply it by. Not quite. Starts with a C.
Cancel.
Nope.
Correct.
Cotangent.
Confine.
Cross multiply.
Concentration.
Oh man.
It's like when we're getting rid of square roots on the bottom of fractions, what do we multiply by?
Oh. No square.
Good.
CO?
Oh, terminal.
No.
Wait.
Conjugate.
Oh.
Oh, I'm sure it was. Okay, so you change the sign in the middle. So we're going to multiply top and bottom by 1 plus sine x over 1 plus sine x. That's the conjugate. I changed the sign.
Oh. Okay.
Yeah, she literally changed the sign.
She literally changed it.
Ha ha. Yes.
What do we? What do we did?
All right, so again, the conjugate is where you look at this one, okay?
How do you spell conjugate?
Conjugate. Right, again, that's when this sign changes and everything else stays the same.
Okay, so when do you know you have to do that?
When it looks like that.
Yeah, so when you have a fraction and you have things added together on the bottom,
Okay.
right, it's helpful. It'll help you get rid of your denominator. Okay, so on top, that's just going to be 1 plus sine x, right, because we're multiplying by 1. On the bottom, we have to FOIL. Okay, so 1 times 1 is 1. 1 times sine x is sine x.
How do you?
Negative sine x on the bottom. This and this. Right, so I have my first outside. Inside gives me negative sine x. And then the last gives me negative sine squared x. So those cancel. All right, so we still have a fraction, right? Okay, what can we change the bottom to?
Take the negative out.
Nope,
Oh.
we don't need to. Look at your sheet.
The square.
What about the squared?
Get rid
You
of
have
it.
to get rid of it.
1 minus cosine squared.
Not quite.
Wait, what's even
What does 1 minus sine squared equal?
1 minus sine.
Cosine squared.
Yeah,
How do you know that?
it's on the sheet. Right, so this is equal to cosine squared.
This is like a lot of fun. I just don't understand it, but it's still fun.
This is mostly us practicing how to deal with the fractions and the other stuff, okay? All right, so now we still have a fraction, okay? I'm going to split this up into 2 fractions now. Right, so I'm going to have 1 over cosine squared plus sine over cosine squared.
Oh, wait, how'd you get that?
I just undid the addition of the fraction.
Why do you still have 2 cosine squares on the bottom though? Why aren't they just cosines, not squared?
Well, because they're...
You can't just unsquare stuff
But
like
I
it.
thought if you had.
No, that makes sense, but we're adding them, not multiplying them. Right, so if I added these fractions back together, right, remember my denominator stays the same.
Oh. That makes sense.
Yep, there it is.
Yep.
All right, so now your reciprocal identities, while they're on your sheet, like not squared, it still works. So like 1 over cosine is secant, right? So since this is 1 over cosine squared, it would be secant squared. Okay, so it works regardless of the exponent there.
Is that the whole point of this lesson?
No.
I thought it was, that it works in your Euclid or something. I don't know.
Okay. All right. I'm going to change this one now. I'm basically pulling out a cosine on the bottom. I know, it's a lot. It's going to be okay.
This is good for you.
I'm basically forcing you to remember everything you've ever learned about fractions right now. And algebra. Right, so this is kind of expecting you to know how to undo all of your normal fraction stuff. I know, it's a lot. I really feel like the hardest part about this is more of the algebra than it is the trig.
Hold on, let me just write real quick.
Okay, so look, if I multiply this back together, I get sine over cosine squared, right? But I know that sine over cosine is tangent. And I know that 1 over cosine is secant, right? So I want to split this up so that I can write it as both of those things. So usually if you have one trig function over another one squared, you want to kind of split it up this way. Okay? Because it can help you break it down into other trig functions.
You see, I get the idea of what you just did. I just don't like it.
Okay, that's okay. That's kind of where I expect us to be at today. Right? I want you to kind of see why I'm doing what I'm doing, right? And then I will keep teaching you how to recognize when to do that and how to do that, okay? I know, it's a lot. I kind of feel bad for everybody that's not here today. I have been recording. I've been recording this whole thing for them, though, so they're still going to...
Hey, guys.
You suck.
Hi, Phil.
Hey, not nice, Isaiah.
How's your basketball going? I hope it's going very well.
They haven't even started yet.
Never mind. Well, if you're listening to this after your basketball happened, I hope it happened good. Happened good. Congratulations.
Anyway, so you get secant squared plus tangent x times secant x.
Alright, guys.
Is that it?
Yeah. We got rid of the fraction.
Oh my goodness.
That was
You guys
fun.
hear my rat noises?
Lakin, please stop talking. Okay, nobody panic. We'll keep doing this tomorrow.